I'm Anil Kumar, and here is a solution of question number 12, page 171. The question here is, sketch the graph of the function g that is differentiable on the interval -2 to 5, decreasing on 0 to 3, increasing elsewhere on the domain. The absolute maximum of g is 7 and the absolute minimum is -3. The graph of g has local extrema at 0, 4 and 3, -1. So that is the question for you. It is based on increasing decreasing intervals. You need to sketch a graph for this particular function. You can pause the video, read it once again, and then try to sketch the function. Once you have done, look into the strategy which I will follow. I hope this strategy is going to help all of my students. Now to begin with, let us just make a rough outline of the graph, right? So what we have here is a coordinate axis, and let's read the question once again. And as we read, we'll form some guidelines, okay? So I'll use a light color to show you the guidelines, and then we are going to sketch the function. Sketch the graph of the function g. So the function which we are sketching is g. Now with reference to, let us say, x is our independent variable. That is differentiable means continuous, right? Without any cusp or corner, that is differentiable on the interval -2 to -2 plus 5. So let us say this is 1 and this is 2. Then we have 1, 2, 3. So let us say this is 2. Then we have 2, 4, and 6. So I'll take this as -2 for me, right? So -2. So this is 2, 4, 6. Okay, let that be the scale. Okay. Now, so the interval for us is between -2 and 5. So we are working, so I'll call this as my rough region, right? So I'll just make some notes here. So we are working from -2 to 5, which is kind of here. So we are working in this interval from -2 to 5, right? So that is the interval. Now it says decreasing on 0 to 3. So from 0 to 3, 3 is kind of here, it is decreasing. So from 0 to 3, the function is decreasing. Do you understand? So that is how I understand this statement. Increasing elsewhere on the domain. So in this domain, it is increasing elsewhere. So it is increasing and it is increasing. So that is how the graph of the function should be, right? Now it also says absolute maximum of g is 7 and absolute minimum is -3. So the minimum value is -3. So I can assume that should be the absolute maximum. That should be absolute minimum. So we are saying this value should be -3 and that value should be 7, right? So that is absolute maximum, which should be at the end point, right? So when we have extremas, so remember one thing, extrema means we have to consider boundary conditions, correct? Now since the boundary conditions for our function is between -2 to 5, these are our critical points to consider, right? So those are the points for our boundary conditions, and we can now make out, because the function is increasing, so that becomes the lowest value and that is the highest value, probably 7, right? We are also given that the function g has local extrema at 0, 4 and 3, -1. Now these are the 2 points where we have local extrema, right? Now looking into the situation, we can say at this point we should have 0, 5. So that becomes our local maximum, right? And this is our local minimum, correct? Now that gives you an idea of the graph itself, correct? So what we can begin by first plotting these points itself. So -2, we have a value of 3. Let's say this is 2 for us. So then this is 4 minus. So that is the value 3 for us. At 5, we had 7. So let's say now we're going by 2s, 6 and 8. So this is 7 for us. So at 5, we have 7. So approximately, that's the end point. So these are the end points for my graph. Now it is increasing and it goes to a local maximum value of 4, which is at 0. So 1, 2. So that is my local value. So that means it is a turning point. Is that okay? So that is a turning point. So it has to be like this on this part. Now it is decreasing with a minimum of -1 at 3. So at 3, the minimum is -1. So it has to turn from here. You get the idea now? So it turns from here, right? And then turns and goes back to the maximum value. Now that gives us the idea of sketching, right? How the graph should look like. Now from these, we can now sketch the graph. So we say now the function should look like this, right? So that is how the graph is. It increases in this interval and then comes down to the local minimum value of -1 and then further increases to the absolute maximum value of 7, right? So this value for us is, this is at 5 we have 7, and here at -2 we have the absolute minimum -3, and these are our local maximum and minimum points, right? So -1, you get the idea. So that should be the graph of the function, right? So I hope this helps. So let's go through this once again. The question was, sketch the graph of the function g. So that is the function g. That is differentiable on the interval. That means differentiable means what? Let me write down here differentiable. It means a couple of things. That means first is continuous, no cusp, no corners. That is what we mean by differentiable, right? In the interval -2 to 5, so that is the interval -2 to 5. Decreasing from 0 to 3, so it is decreasing from 0 to 3. Increasing elsewhere in the domain, so increasing elsewhere in the domain. Absolute maximum of g is 7, so that could be on the extreme points. And absolute minimum on -3, again the extreme points, so we got them right. The graph of g has local extrema at 0, 4 and 3, -1. So these are your local maximum and minimum values. So that is how you can confirm that this graph is absolutely correct. I hope that helps. Thank you and all the best.